Let's learn in this video how to create a complete CI/CD pipeline in Azure DevOps in order to deploy an application into a Kubernetes cluster. This pipeline will start first by the basic steps that will go to build, tag, and push the image into a container registry, and then deploy the YAML manifest files into a Kubernetes cluster. But to these steps, we'll add more additional steps. So we'll go to add steps for scanning the application source code, scanning the Docker file, scanning the Docker image, and also scanning the YAML manifest files, all of these inside the build stage. And we'll add to that the running of the unit tests for our application to make sure the package or the output of this build pipeline is conform and it does respect all our best practices. Then in the release pipeline, we'll have actually three stages. First stage to deploy into dev, and then deploy to UAT or QA environment or pre-production, sorry. And then the last one that will go to deploy into the production environment. To these stages, we would add other steps like running integration tests to make sure that the application and the databases all are running as expected. And then we add other steps for running or for scanning the cluster configuration to make sure our environment respects all the good practices. So let me start first with the prerequisites for this demo. So here I have the application source code hosted on this GitHub repository, and in the previous video I have already created the basic pipeline where I showed here the different steps for building and pushing the image into a container registry, and then changing the image tag into the YAML file, and then deploying the application into the Kubernetes cluster from here. And as a prerequisite also, I have created my AKS cluster within the Azure, that is the Azure Kubernetes service, a managed Kubernetes service in Azure. And I have also created a registry in Azure using the Azure Container Registry. And here I have the repository for my web app images with all the tags that I have pushed. And because here all the pipelines are defined in this GitHub repository, you would find here the pipeline that we'll be using today, which is the one number 2 for Azure pipelines. I have imported that pipeline into my Azure DevOps account or project. So you can go to pipelines and then go to create a new pipeline. And then you go to select either Azure repo Git, or you select directly the GitHub repository. I'll continue with Azure repo Git, and then from here I go to select the template, which is an existing YAML pipeline, and then I choose my YAML pipeline from the folder number 9, so choosing Azure Pipelines, then continue, and that will import the pipeline into your Azure DevOps. I have already done that step, so here I'll jump directly into the pipeline that I'll be using today. But let me first, because here I have actually lots of tasks to show you for this pipeline, let me just show with a small overview about all of these tasks, then we'll go to the technical details. I hope you will understand my writing on this schema here. So this is resuming all the steps that we'll go through in the pipeline. So first of all, we will have our application source code, the unit and integration tests, and the manifest YAML files, the element charts, all of this defined into the developer laptop as files. Then we go to create a commit or pull request to push all of these files into a Git repository, and then through that commit or that pull request will trigger the build and release pipelines. So first it will trigger the build pipeline, where here we have in white color the basic tasks. So first of all, we would go to run the command docker build in order to generate the Docker image, and then tag that image with the new tag, and then we go to push that image into a container registry that could be Azure Container Registry, ACR. And then that will trigger the release pipeline, where the basic tasks here will be to connect to the Azure subscription using an SPN. SPN stands for Service Principal, that will give my pipeline or my machine pipeline access to my Azure subscription. And then we can run the commands AKS get credentials in order to get the kubeconfig file that contains the credentials to my AKS cluster. And then I'll go to run kubectl apply -f, then my YAML files for my application. So those are the basic tasks for CI/CD pipeline for Azure AKS service. Let me add here some other interesting steps to make this pipeline a complete pipeline. So what I have in colors here is the other tasks that I would add. So firstly, I would add actually another task for scanning the image. So after generating that image, actually, and right before pushing that image into the ACR, I want to make sure that image is secure. I don't have any security vulnerabilities, any security threats, and so on. So I would scan that image, and there are multiple tools that will allow me to do that. One of them is Aqua Security 3V, and you can also use ACR. It provides a service called Azure Defender for ACR that can scan all the pushed images into the ACR. Then I want to also scan the Docker file, and probably I would do this before scanning the image and even before building that image. Okay, so here the order, it's not really an ordered list, I just put it like this. So I would scan the Docker file looking for any missed configuration in the file itself. So to make sure that Docker file respects all the best practices defined by Docker images. And then I have some other configuration files, which are maybe my YAML manifest files for Kubernetes and the Helm charts. I can also scan these tools, and we can do that through a well-known tool like Chekhov, but there are also lots of other tools known for doing these kind of tasks, like kubelinter or kubesec, for example. And then I would also go to scan the application's source code using a tool like SonarQube. There are also lots of other tools. So that will allow me to scan the application source code, looking for any passwords in my application or any misconfigurations if it doesn't respect some of the well-known design patterns and so on. And then also I can run my unit tests either inside the Docker container or outside that container. And that will allow me to make sure that my application doesn't have bugs. So this will be part of the build pipeline. So we'll go to run all of these steps together to make sure the image that we have generated, it's a secure image and it respects all the best configuration, the good configurations, and it doesn't have any missed configurations. Once that's done successfully, all of these steps run successfully, then that will trigger the second part of my pipeline, which will run inside, let's say, inside another stage in Azure DevOps that is called the release. And into the release here, we'll go to run some steps. So we still run the basic ones for logging to the Azure subscription, getting the credentials, applying the YAML files, but we can also add some other steps. An additional step could be like running the Helm chart. So instead of using YAML manifest files, you can use Helm charts. And for that, you can replace your kubectl apply-f with Helm upgrade or Helm install to install your application's charts. And then we would go to scan the application's the cluster configuration, and are looking for any misconfiguration within our cluster. And there are lots of tools for doing this, like Kubebench, for example. And then we can add other steps like pulling the secrets from Key Vault and writing these secrets into the cluster, or integration with pod identity or with CSI driver in order to run these scenarios. And then to validate the deployment, we would run some integration tests to make sure that our application is running as expected within the cluster. So this is all of these steps will be run for each of my environments. For my application, maybe I would have dev, UAT, and production environments. So for each of these environments, I can run all of these steps. And going from one environment to the other, that migration will run only if the previous environment or if the previous steps for that environment runs successfully. And until I go to run production, then at that stage I would add an additional constraints, which is a manual validation, because I don't want to deploy into production immediately. Maybe I'm waiting for validation from my sales department or from the marketing department. So for that, I can add a manual step where one of the team members should receive an email or a notification asking him to validate the deployment to production, and that will not happen unless that person validates that deployment. And of course, there are some steps that I didn't represent it here, like for example, uploading the Docker image or uploading the YAML manifest files or the elm files into the release pipeline, so they will be available from the release pipeline, because the release here might run in another machine than the build pipeline. So I need to upload and to share those files with the release machine. Let's now go to check the implementation of this pipeline. So here I have that implementation. So that will start with a trigger, which is commit or pull request on the main branch, and then that will run on the Ubuntu latest machine. And then I'm defining here a variable tag, which will be used to tag my new image. And then I have some parameters here. I didn't use it in this demo, but just to show that we can have those kind of parameters. Those could be changed when we start running the pipeline. So when I go to run here the pipeline, it will ask me to choose for the pool image, to choose one of these three images, Windows, Ubuntu, or macOS, or I can also choose to run all the tasks with this flag right here, so I can check it out or not. And then here I start defining stages. So I have here actually 4 stages in this pipeline. If I do this, so you have one stage for the build, and in this stage I go to create the Docker image, push it into the ACR, and then perform all the operations for scanning the image and the application source code and the YAML and Helm charts. And then I have other stage for releasing. So I start first with releasing or deploying into the dev environment to QA, and then deploy into the production environment. Let's take a look at the first stage for the build, where here I go to build and push the image. That's the display name of this stage. And then I define here actually 2 jobs. So first job will go to scan and test the application and the configuration files. So onto that step, I'll go first to use Chekhov as my tool. So first I install Chekhov into the build machine, because it's not installed by default. So I write here down all the scripts in order to have Chekhov installed in my machine. After that, I go to use Chekhov in order to scan my Docker file. First of all, so I'm using the command line for Chekhov using this script. So I put here the folder of my application where I have the Docker file, and then that will go to scan it. Then I use also Chekhov in order to scan the application or to scan the YAML manifest files for my Kubernetes cluster. So I put here Chekhov -- directory and then the folder for my Kubernetes YAML files. After that, here I go to run some unit tests. So because in this demo I don't have unit tests, so I'm just putting here that task, that you can replace it with your unit tests. And then I go to scan the application source code. So again, here I'm doing the same thing. So I'm just putting a simple task just to demo that you can put that task into here, and you can replace this with SonarQube, for example. So that's the first job, in order to make sure that the application source code, the YAML files, Helm charts are all well configured. And once that's done successfully, I'll go to run the second job, which depends on this first job. Okay, and that job will go to build the image. So that's the main purpose of that job. It will go first to build the container. So for that, I'm using a script that will go to use docker command, docker build -t. Then I'm following the tag here with for that image. So remember, this is the tag that I have defined earlier. And to here, that will go to have a fixed number with the build ID. That will be, this is a variable defined within Azure DevOps that will be auto-generated each time we run this pipeline. So the image then will be generated into the inside the build agent, and then I'll go to scan that image to make sure that image respects all good practices and all the good configurations. So for that, I'll run here a Docker container. That container is actually the one from Aqua Security Trivy. So I run that container and I'll pass to it an argument that is the name of my generated image, the one that was generated before. And then I'll ask for the findings, medium, high, and critical findings in terms of severity. And after that, I'll go to push the container into ACR. So here, using this task, actually it's an Azure CLI. I could actually here run some ACR tasks. So if I look for Docker here, I have a task for Docker that will allow me to perform these operations. But here I prefer for some tasks to run just the simple command line that would be much simpler, and it would also give me more control. I can do with that command whatever I want to, so I can personalize and I can customize this command as I want to, because this task will constrain me with some tasks, with some commands, sorry, and then I have just some limited configuration here. So I prefer here to use Azure CLI, and note this Azure CLI, actually it will go to connect to my Azure subscription in order to be able to run or to connect to my ACR. So that will ask me first for the connection for the service principal that I have already defined in my Azure DevOps subscription. And yeah, as you can see, that's the service principal that I have defined there. And then I can use one of the shell script types, and then I put the script in line, which is this one here, that will go to log in into my Azure subscription. So at this time, I'm already logged into my Azure subscription thanks to this service principal. So I can perform ACR login, then the name of my ACR to login into ACR, and if I do that, then I will be able to perform Docker push in order to push that generated image into my ACR. Once that's done, actually I can move to the next step, but I could also done these two steps using one simple command, that is building the container inside ACR, inside Azure Container Registry, because it have that feature where I can go to upload the application source code and then ask ACR to build that application using the Docker file inside that application source code, and that will go to perform the build and also perform the push inside ACR. So that's optional. For that, I've said here that would be optional. Preferred way is to use this way here, where you go to build the image into the build machine, okay, so that you can scan it later, okay, because if you do this option, then it will be the build will happen inside ACR, and if you want to scan the image, you need to download it again in your build machine. Then I'll go here to think now about the YAML files for my Kubernetes application. So I have that app deploy.yaml that contains the tag for my image. So I need to update that tag. So for that, I'm using this task. This could be actually a PowerShell script or any shell script that will go to look for the tag for my image and then upload it or update it with the newest tag that was generated in this pipeline. So this task actually will go to look for the variables that I have here. So I have the variable tag. It will take this value from here, and then it will look for my app deploy YAML files and look for any token that have the same name as the variable. So it will find this one, which is the tag for my image. So, and it will go to replace all of this one with the real value of the tag. Once that's done, I want to verify that tag was updated. So I'll go just to show the content of that value, to view the content of that value using the cat command from here. And then I'll go to upload that manifest, that updated manifest file into Azure DevOps artifacts. So I'll use here this command publish build artifacts, and then I go to publish it into a folder, into the drop manifest folder. I'll do the same for the Helm chart because I have a Helm chart in that application. So I'll go to upload also that Helm chart. Here for just a note, you can upload the Helm chart into ACR, into Azure Container Registry itself, and save it there and create multiple versions and so on. So that's also another option. So these two jobs are part of the build pipeline, where here I just create the image and then push the image, and then after that I scan those configurations. After the build stage, I go to run the releases stage. So here I have 3 releases because I have 3 environments. So first release will deploy the application into the dev environment, and here it will run into a pool. I can change that pool right here if I want to, and then I can go to first actually download the build artifacts. So I specify here the folder from which I want to download the latest manifest files. Okay, I'll download it into the artifacts directory, and then I'll go to run the command deploy kube control apply -f then my files, and that will be done with this task. So first here I need to actually connect to my AKS cluster. So for that, I'm using here the Azure Resource Manager, and I'm specifying the service principal that I have created earlier to connect to my Azure subscription that will allow the pipeline to perform AZ login using that service principal. And then I specify here the resource group for my AKS cluster, so I find it right there. And then I specify also the name of my AKS cluster. I put those variables, and then I put here the namespace where I want to deploy. So here I just chosen to deploy into the default namespace. That's not a good practice, so you should change this into dev, for example. And then I specify here a command. So I want to run kubectl apply. So here you can view all the kubectl commands like create, delete, expose, exec, and so on. And then I'm going to use configuration files, specifying the file path. And here I put the path where I have downloaded the YAML manifest files from the drop folder. So that is the first job in this release to the dev environment. The second job will go to run integration tests. So for that, I'm creating that second job. And the objective here is that I will run my integration tests. Here I have just put a simple task with the command saying you should run integration tests from here. But yeah, you get the idea. From here, you would add the needed tasks in order to really run those tests. Stage number 3 is the deployment into the QA environment. So here I'll do the same as before. I go to download the Helm charts, and you see here the difference with the previous stages, that now I want to use Helm charts instead of YAML manifest files. So to deploy those Helm charts, I use another task that is called Helm deploy. And with that Helm deploy, I specify again the connection to my Azure subscription, the resource group name, the AKS cluster, and then the namespace where I want to deploy. In this case, it will be called QA. And then I would choose the elm command. So here I choose the elm upgrade command, and then specify the file path where I have my Helm charts downloaded from the artifacts. And then I want to call this chart first up, for example, and I have some values to override, like here the image tag that was defined in my Elm chart. So I have image.tag, and here I specify that the correct image tag. Note here, this chart is actually not deploying this current application, but it's deploying a sample Nginx application. So I choose this version right here. And then I want to deploy this into the namespace QA, so I specify that value right here also. I would have other configurations, like to wait for that deployment to be complete and install if release not present. This is the first time this pipeline runs and doesn't find that Helm chart, because here I have chosen the command upgrade somewhere here. So the first time it will, if it doesn't find that chart to upgrade it, it will go to install it. And then I have added another argument that is create namespace. If in case doesn't find that QA namespace, it will go to create it. So this is represented here, another way for deploying the YAML or deploying a Kubernetes application, either using YAML pipelines or using YAML files or using Helm charts. So I'm showing actually both options right here, and it's up to you to choose. But here, if you choose to deploy YAML in your dev environment, you will typically choose to continue deploying that same YAML into all the other environments. Okay, here I'm just switching from YAML to Helm just for demo, from demo purpose. And the same, if you started with Helm in your dev environment, then you will continue deploying that same Helm chart into your QA and your production environment. Let's move to the second job from the stage for deploying into QA, which is running integration tests, again, as we have done before. So you should run this from here. And then last stage is the deployment into the production environment. So here, before moving to that production environment, I want to add a manual step that is validation of an external or from a person. So here I added this task that will run only on a pool server. That means it's not one of our servers, okay? And that will run the task manual validation, where here I should put the email of the person, one of multiple emails, or a distribution list for the persons who should perform the validation of the deployment into the production environment. And here I'm describing for them what they should do as the instructions before they go to validate, asking them to verify the configuration and resume. And from here, they once that timeout that I have put here into 1 minute just for demoing, if that expires, then what is the default action? Either to resume or reject. After that, once they resume, so that will go to perform the second job deploy, which depends on the first job that was called wait for validation. So that creates that dependency, and then here all the actions below will go to deploy that Helm chart into the Kubernetes cluster. But first we need to download that Helm chart into the build agent, and then we go to deploy that element chart. But not here. We are deploying the element chart using the command line. So here I'm using actually the Azure CLI to first connect to my Azure subscription. So if I click on settings here to view that configuration, I have actually first specified the SPN to connect to my Azure subscription again, and then I'm running some AZ AKS get credentials to connect to my AKS cluster, and then just for demoing I'm showing the cluster info to make sure I'm on the right cluster, and then I'm running the command helm upgrade -f values, overriding the image tag, for example, and then specifying the load balancer and deploying that into the namespace production, and make sure that namespace is created and created if it doesn't exist. Once that's done successfully, we would have our application deployed in the Kubernetes cluster. After that, so we'll move to running the integration tests to make sure that that application was deployed successfully in my cluster. And then here I'm adding another specific task that will go to run also Azure CLI, but this time in order to connect to the AKS cluster and also perform scan of the cluster itself. So I'm using here Aqua Security Kubebench tool that I have talked about. So you can find that tool right here in this GitHub repository, and you will find it in the documentation how you can use it. So I'm running here all of those commands in order to deploy the job that will go to deploy the Kubebench, and then I'm retrieving the name of that pod, and then I'm checking the logs of that pod because the findings will be outputted into the log, and then I'll go to delete that job. And I'll do the same for that job that is specific to AKS. So we have first job that is generic to any Kubernetes cluster, and another job specific for AKS to find more findings actually. So I'll deploy it, look for the job ID or job name, and then output the logs from that job, and then delete that job from my cluster. Okay, so this makes like 344 lines of code for this pipeline. I know it's too long. You don't need to copy it like this from the screen because you have that pipeline in this Docker Hub, in this GitHub repository, where here you can find that pipeline, and you can go copy it and import it in your pipeline and run it and change whatever you need to change in that pipeline. Let's see now a sample running for that pipeline. So here I go to the list of runnings, and let's check, for example, this one here, where I can find the definition of all the stages. So the stages for the build that will perform scan, test, code, build, and so on. So I can get this nice representation of the content and of the jobs and the stages in this pipeline. Let's start first with scan and test code. So here I would find all the steps, and from installing checkoff, scanning the Docker file, and we can find the findings for scanning that Docker file. So here it tells me, for example, health check instructions should be defined in that Docker file. The user, I should create a user into my Docker containers, and some of the other checks to make sure the base image doesn't use the latest image, and so on. And then I would scan the YAML manifest files where I have some findings found by Chekhov. One of the findings is that I should not deploy into the default namespace. I should deploy to another namespace, then minimize the admission of containers. Some other findings like containers should run as high UID. Some others, image pool policy should be always. We should not keep it using the default one. And then I should constrain the net row. I should specify the security context for my pods and containers, and it gives me where that finding was found in which file, into which YAML file. And then running unit tests, scan the application source code, and once that's done successfully, it will go to move to the next job in order to build the Docker container. So here it's building that Docker container, scanning the container. So here it will run the command for scanning the container using Docker container from Aqua Security Trivi, which is, by the way, is one of the open source tools available so from within Aqua Security. That is this repository right here. And also for Chekhov, you can find it also on GitHub, and that is this repository if you wanna use it. Coming back to my pipeline, so after scanning that container, and here, happily for me, it doesn't find any security misconfigurations. Otherwise, I would find a list of recommendations right here in the output of the pipeline. And then I go to push the container into ACR. So here first it's actually making sure that AZ is installed on my build agent, and then it will go to run the command AZ login using the service principal, specifying the user and password that it will find inside the service connection that I've created in my Azure subscription. So this is making sure that the build pipeline connect as a machine, not as a user, by using service principal. And then after that, it will go to set the correct Azure subscription, AZ account set, and then it will go to run the command docker build, or docker push, sorry, in order to push the container into my ACR repository. And the optional task here that I have specified, which is running the build and the push inside the ACR itself. So here I have all this output coming actually from ACR. So that's performing the build of the agent, the build of the Docker image into ACR. That could be useful if inside your build agent you don't have Docker installed, for example. And then replacing the tag into my app deploy.yaml file and viewing that if that tag was changed, and I can see that here, yeah, that tag was changed, and here I get that new tag value 1.00, and then I have here the build.build ID value coming from the Azure DevOps running. And then I go to upload that YAML manifest files into Azure Artifacts, which is a folder defined inside Azure DevOps services. And that folder, I can access it later from my release pipelines. After that, I go also to deploy the Elm charts. Okay, and then I'll go to the deployment into the dev environment. So first thing that will be done automatically for me is downloading the application source code, even if I don't need it actually right here. Then I go to download the artifacts. So here I'm downloading those YAML manifest files, my app deploy, config maps, and so on. And then I go to deploy that YAML manifest into my Kubernetes cluster. So for that, using the command kube-control apply -n, the default namespace, and specifying the files coming from the drop manifest, and then outputting the content into a JSON format. So I can see here all the files that were deployed into my cluster. So those are the basic steps. After that, I go to run another job that will go to run integration tests, for example, and so on. Next, deployment onto the QA, where here I go to download the artifacts, deploy the Elm chart, and here it will go to specify the elm upgrade dash dash namespace QA install. If it's not installed, specifying the image tag that should be changed, and then specifying the name of my namespace, and all the rest of this configuration in order to deploy that Helm chart. And then after the deployment into QA, I'll go to run some integration tests, and then I'll move to the last stage, which is the deployment into the production environment. So first, for here, it will ask me for a manual validation. So here, I don't have that represented here, but here it would show you like a blue button saying, hey, please can you validate the deployment into production, and you would have two buttons like apply or like accept and reject. You click accept, and that will trigger the next job, which is the deployment into production, which will again check out the application source code, download the artifacts for the Elm chart, and then deploying the Elm chart using the Azure CLI command line. Okay, so again, that will perform all the needed operations, looking to the Azure subscription, and then downloading the kubeconfig file for my Kubernetes cluster. Okay, and then it will go to upload or to actually install that Elm chart into my AKS cluster. So here it shows me the output coming from my Elm chart, and then it will go to perform AZ account clear in order to delete the service principal from my machine. After that, it will go to run the integration tests inside my production environment. So running the integration tests first, and then maybe scanning the cluster configuration using a tool like Kubench. So first, I need to connect to my Azure subscription, connecting to the AKS cluster, downloading that kubeconfig file, and then it will go to run the command for scanning the cluster using Kubench. And oops, it seems here I have an error for my script. I didn't wait enough time for the container to be created before showing its logs, but I can show you a sample output of that of these logs. So first here, when I'm applying that job into my AKS cluster, that's the Kubench tool actually, then I try to get or to output the logs of that coming from this job right here using kubectl logs. I show the logs, and here are the findings from my cluster. So first we'll go to scan the worker node security configurations, showing me here the worker node configuration files. It will make sure here showing the permissions, the authorities, and all the related stuff to my AKS cluster. And then here it will perform other kind of checks for the Kubernetes policies to check the airbag and service accounts, telling me here the cluster admin role is only used where required, minimize access to the secrets, and making all of these kinds of checks within my cluster. And for each finding or for each scan, it will give me more details why that should be activated or not, and what are what is the impact on my cluster. I'm performing the same thing here with the job for AKS. Again, you can find these files in this link on the Aqua Security Kubench file. And then I'm checking that job name. Once I get the name, I'll go to output the logs from that job. So this one here will check against the worker node security configuration, showing all the findings here, which are the ones that passes and which are the ones that fails, warning or info. Great, that was all for me today for this pipeline, this complete pipeline that deploys application into Kubernetes cluster. Remember always that you can find the YAML pipeline that we have created earlier into this GitHub repository, and the source code is available here. So thank you.